where you put things off, you're not going to get it done.
Yes, that's somewhat true. It's called avoidance. All right, here we go. Shh. All right, real quick, guys. What is the y-intercept here? Isn't this plus 0? So if it's plus 0, that means it's proportional, right? Because there's nothing there. All right, now this one, the y-intercept, so this one b equals 0, proportional. This one b equals 2,000, so that is non-proportional. That's not a very good end. Non-proportional. Proportional. This one you got to be careful because they flip-flop the order. This is the y-intercept, right? Remember that the number in front of the variable is the slope. So the y-intercept in this particular case is 450. Non-proportional. Yeah, either way, if you have something other than 0, it's non-proportional, right?
Yep.
And then this one is plus 0. So b equals 0, so that's proportional. Because it goes through the origin. If the y-intercept is 0, that means it goes through the origin. If it goes through the origin, it's proportional. Okay? Let's move on to the next slide. This is example number 3. Shh, you guys pay attention. We're almost done. The values in the table represent the number of U.S. dollars 3 tourists traded for Mexican pesos. The relationship is linear. What's that mean? No, it doesn't mean that it goes through the origin. It means it has a straight line. So that's the first qualifier. Is the relationship proportional or not? So now this one, we got to do the old school proportional. All right? So what we're looking at is the y value, right? So we look at the y value divided by the x value. It reduces down to 13. We look at this y value divided by this x value. It reduces down to 13. This y value divided by this y value reduces down to 13. So it is definitely proportional. Because the relationship between y and x is the same every time, 13. On the non-proportional items, when you go to do that, you get wonky numbers. They don't equal. So it's non-proportional. Okay? Does that make sense?